this printer supposed to be for children? Hey guys, welcome back to PrintFixFriday, episode 28. We got some spicy fails in it for you, and if you stay to the end, boy, there's a Grant rant coming, so hang on. We're going to start off with the thing that I've talked about here multiple times, brass nozzles hitting that carbonium crap that Creality puts on their build plates, basically sending your nozzles flat, and how do you solve that problem? From there, we move into Z-axes that are not cooperating. Could be heat, could be mechanical. Let's find out. Then we move into not exactly a failure, but a failure detection system from the company 3DQ that I need your help so that we can take a look at it a little bit closer. But most of this video is completely pushed toward the video put out by DeWitt 3D Canada, good friend of the channel, who was taking a look at a 3D printer and was thankfully live streaming because, well, shit hit the fan. This is a very ranty PrintFixFriday, but I know you guys like that. But what you don't like is my segue to our sponsor, 3D Musketeers. We know failures suck, and if your printer starts to catch fire or for some reason doesn't have thermal runaway, yeet it into a low Earth orbit and then go ahead and call the pros over at 3D Musketeers. We can help you unfuck that failure and get your printers running well by buying a better printer. But if you're not looking to print anymore because that just gave you a real bad taste in your mouth, I'm not going to blame you, and you can use one of the almost 40 machines that we have here to make your dreams a reality. The pros at 3D Musketeers have over 40 years of combined experience helping people make awesome every single day. Myself, over 14 years. It's kind of crazy that it's been that long. But if you want to help out what we do here on the channel, you can do so over at Patreon, patreon.com/3D Musketeers. Kick a couple of bucks toward the fund of making awesome videos just like this one multiple times a week for you. And we are actually looking for podcast guests. So if there's anyone that you would like to see on a future podcast, comment below and let me know, or have them reach out to us, YouTube at 3dmusketeers.com, because I would absolutely love to talk to some other creators, makers, and awesome people in the industry. But enough of the call to action. Let's get back to those fails. Tried to level the bed with a G-code. It did all corners 5 times. Count them. 1, 2, 3, 4, 5 times. And this happened. Tried again, number 6, where I changed the offset and nothing happened. What am I doing wrong? Well, your nozzle's screwed. I can tell you this right now because this is nozzle embedded into print surface. And if I'm correct, this is their special fancy carbonium bullshit. That's basically silicon carbide and has ruined your nozzle, or has flattened it out quite well, and maybe that's not going to hurt it all that much. But what's gone on here? If you've ran the G-code 5 times, where are your screws at? So on an Ender, this is clearly an Ender 3, because Ender, where are the screws at? So Enders are all manually leveled unless they've been upgraded, or it's the new Ender 3 S1 Pro, because naming schemes. If it doesn't have auto leveling, you gotta make sure you work on those screws on the bottom. If all you're doing is adjusting your Z offset at every corner, it's not holding everything. So you have to go through and make sure everything is right. Something tells me that we still have a problem here. If you're not adjusting your bed and you're just raising or lowering the Z-axis manually, that's where you're going to run into some problems because it's still homing at the exact same spot. One thing you can do here, if your screws are all the way tightened and there's nothing else you can do, raise your Z-axis up some. On the side of your printer, you will find the Z offset limit switch. When you're looking at the front of an Ender 3, it is normally off to the left side, and it should be 1 or 2 hex bolt screws, and move it up ever so slightly. You know, a millimeter or 2 should be enough to get you off of this print bed, and then be able to work the knobs yourself. But this is a case of just make sure you level the bed appropriately. Let me know in the comments if you guys want us to do videos like how to level a print surface and all that. I feel like it's kind of been overdone, and I don't want to create a video that people are gonna be like, I've seen that a Brazilian times. I don't care about that at all. But if you think it might be useful, I'm happy to do it. And that would also give me the fun time of just hitting first layer calibration on a Prusa and let it auto calibrate and say this is how it should be, and this is what you're dealing with. But that would also segue us into doing upgrades to an Ender, so maybe that is useful. Let me know down in those comments. But this is something to watch out for, because if your nozzle is dragging across your print surface like this, one, you should have noticed way earlier, right? Like, come on. You could have seen this. You weren't paying attention. It's fine. But what's occurring here is you're literally sanding down your nozzle. Now, if your nozzle's directly vertical with your build plate, you might be okay. Realistically, you're not putting a lot of brass onto that build plate, but it's not a little bit, right? There's a measurable amount there. So you got to make sure you clean off your build plate. Little isopropyl rubbing alcohol, 90% or higher is my preference. Go ahead and clean that thing off and try it again. But make sure that you are either adjusting your screws on the bottom, they'll be big thumb wheels, or you are raising up the Z-axis manually using the Z-axis limit switch. Hopefully that works. I think this is a pretty common problem that we see. Z-axis went MIA during print. Slam into bed when position reads 250. Sent 100 millimeters up command from Octoprint, and this is what happened. Rebooting only solved the issue. Next print can be perfect or total mess. It happens more frequently on hot days. Garage can sometimes get above 90 degrees. Warning! This is a very annoying constant sound. I will probably have our editor mute the video after, I don't know, 5 seconds of this bullshit. Alright, so who's running the jackhammer here, right? Like, what the actual fuck is going on? Alright. That's enough. I've watched the whole video. He just kind of goes around things going... What is this, an old Browning? I didn't know that 3D printers were now machine guns. But what's going on here? Alright? The stepper is clearly bound up. And whether that's because it is hitting the bed or your axis is tilted and it's not able to go up at all and it can only go down, I don't know. We've definitely got some issues here. Heat is something that I don't know if I'm going to attribute. It could just be lucky. You know, well, maybe not. Let's think about this. If heat is causing it to be more of a problem, it could be overheating the stepper driver. Check your stepper driver. This is not a stock printer, right? For those that didn't notice it, let's go back. It's not a stock printer. It's got a new shroud over it. It's carrying a camera. It's got some drag chain. And while the camera isn't attached to the Z-axis, there's some extra weight here. And if that Z-axis stepper was like right on the verge of skipping, this could cause it. But that fast sound is more from your mechanical failures rather than your electronic failures. But, I would still check it just to be safe. The other thing that I'm noticing is it looks like we are running a Pi, maybe a Pi 0. Sometimes those Pi 0s are not strong enough to run a print well, and their buffers can overflow, and they're generally okay, but sometimes they can be pissy. If it's not setting the appropriate G-code to your printer, you might have a problem there too. But if you're telling me it's temperature-based, I have to kind of say, check your stepper drivers, because if they're really freaking hot, you've got a problem. And I'm apparently not alone on this, right? Probably electronic if it does it more often in the heat. I've had lots of electronic gizmos die when they heat up. I've never seen that before, so take it for what it's worth. But if it were me, I wouldn't let the motor stall like that. Might fry the windings, although they might have been fried already. I'm curious as to what it is myself. I have to agree here. You don't want to let steppers that are going that hard in terms of their failure to keep going like that. That's not safe for them. This would be an instant oh crap button, shut off the power supply, hit E-stop if you've got one. I've seen this happen on Enders where, especially for the dual axis Enders, the ones that have 2 Z-axis lead screws, if one screw's a little bit higher than the other, the axis can bind as it's moving up. If you did recently tighten your V-wheels, which we talked about in the Ender 3 maintenance video, we'll card to that so you can take a look. if you tighten them too much, you can apply too much friction to your motion system, and that little wheedly tiny stepper motor won't be able to do anything. Because ultimately, stepper motors are based on torque, and the thicker the motor, right, the taller the motor is, the more torque it's going to have. It's also going to require more amperage. Those smaller steppers can overheat pretty quickly, and they're not able to draw a ton of current. I would verify that your motherboard is not overheating. I can't get beyond these two little sentences here where it says it happens more frequently on hot days. Garage can sometimes go above 90 degrees. And I laugh at that because my garage is over 90 degrees. It's 10 o'clock at night and it's 75 outside here in Florida, otherwise known as it's hot as sin in my garage. And we run printers out there from time to time without any major issue, so I would check your cooling on your steppers first. If that's not the issue, let's go ahead and look pretty quickly on your Z-axis itself, make sure it's not off kilter for some reason, and then go ahead and try to move it manually. If you are running into any issues trying to move it manually, and that is shut off the printer, turn the printer back on. This disables your stepper motors. Go ahead and try to turn the Z-axis manually. If you are getting any resistance, your stepper motor is likely not going to be able to work through that. That's just something to be aware of. So I would start with electrical, then work my way toward mechanical. Maybe the heat is a bit of a misnomer. It could be an expansion and contraction thing. I doubt it is. The more likely thing to me is that we have a electrical problem going on here. Pretty easy to solve, a little bit of an extra cooling fan in the electronics box, and maybe go ahead and turn down that stepper motor driver ever so slightly, and life should be good. This one is not a failure, but it kind of is. This one comes from my friends over at 3DQ. We've been talking with them a little bit about doing a video on this software, so if you guys want to see a video all about this crazy level of automated print failure detection, that to me is kind of like if the spaghetti detective just did a massive line of cocaine and was incredibly crazy accurate AI. Let me know. I'm trying to convince them to let us get a early copy of it so we can mess around. But I also want you guys to go over and bother them to set up a Patreon, because as any small business knows, getting capital is difficult. And when you're trying to do something like this with an AI, capital is going to be a big deal. So we're going to link to their Discord down in the description as well. I really like these guys. I had an almost hour-and-a-half long conversation with one of the co-founders to kind of talk about what they're doing, how they're doing it, and some good ways to raise capital. But let's take a look at what they're doing, because I think you're going to like it. Because 6,000 people agree with me here. So for those of you that haven't figured this out yet, you are not looking at a live 3D print. What their software is able to do is they're using photogrammetry, and literally people in the Reddit comments were just taking their phones, taking a video of a static print. They were walking kind of around a static print, shaky as all sin. They were taking those images, they were creating a 3D model out of it, then they were running it through their algorithm, which is picking up under extrusion, warping, a little bit of spaghetti, more warping, poor bridging and overhangs, and it is incredibly accurate, right? That's some under extrusion. We've definitely got some spaghetti. Like, hold the motherfucking phone! That is so cool. So cool. I want to talk about this more, and I need your guys' help. Reach out to them. Put some comments down below. Go to their Discord and say, we want 3D Musketeers to take an early look at this. Because honestly, this shit is cool, and I would use the absolute hell out of it as someone that is building a print farm. This kind of thing is incredibly valuable. And if you didn't notice, this is one of 3DQ's print farm enders. They make print farm adapter kits for printers like Prusas and Enders that basically turn them into belt printers without the problems of dealing with belts. We're not going to get into my feeling regarding certain belt printers, but I think this is a great option for those that don't want to deal with belts and already have a fair few Cartesian printers laying around. They even support Ultimakers with a really cool system to eject the parts. And we've looked at Spaghetti Detective before. I never did a full video on it because we were getting way too many false positives. This system is seriously like the Spaghetti Detective just did a massive bump of cocaine. You are looking at a crazy accurate system that can detect live. It's not as accurate live. The big thing that it struggles with is if the part is moving forward and backward from the camera, as the algorithm looks for things, it's going to change its circle or its rectangle around the problem. So their recommendation, if you're going to do it live, is that you attach the camera to the print bed so that the part always stays within a certain focus level. We've also seen some people that will use Octoprint to do this, where they'll take a photo and then it can analyze it from the photo, which is probably what we would do, considering we have the Octoprint camera set up right up there, as well as a webcam in the form of a Wise Cam that can watch the machine. So there's options that are available. I would love to take a look at this. Let me know what you guys think down in those comments. But if this is something that could be offered to the community, maybe free for a few API hits a month with a paid version, this would be awesome, especially for those of us that run 3D printing businesses, to be able to detect this stuff when we're not around. Because even though we all tell you not to run printers unattended, you're not going to listen to me because I don't listen to me. And we're actually going to show you some of the dangers of running 3D printers unattended, so make sure you get subscribed. Now, caveat to that video that we're working on, it's not all that realistic. It's more about thermal runaway, which we're going to get to here next. If you want to see what thermal runaway actually looks like on a printer, we're going to let one go nuclear outside so you can see what happens if you have a dangerous printer like the one we're about to see. Let's take a look at this one. Warning! I'm about to get really pissed. I have watched this video in its entirety, and I reached out to DeWitt and said, brother, I gotta make a video on this because this pisses me the hell off. And clearly, I am one of almost 3,000 people that feel the same way. This printer is a death trap. It is an absolute fucking death trap. We're gonna see why here in just a second. But this is supposed to be a 3D printer for kids. And this was a machine that they got for an unboxing and review on their YouTube channel, right? Happens every now and then that reviewers get this kind of thing. And I think they were incredibly lucky that they decided to stream it on Twitch, because I think that saved them an insurance claim. Let's take a look.
I have to take a break for a minute, but I'm going to start.
Don't leave prints unattended. So we're gonna fast forward to where things start to get a little bit rough. So we're printing okay, right? You know, first layer looked okay, second layer's looking okay. No issues so far. Stepper motor's in an odd place, but for these cheapy printers, you kind of expect this. And we're losing steps. Ladies and gentlemen, this thing is wiggling more than a wacky wave with an inflatable arm flailing tube man, and it appears that it has just snapped the freaking heat brake. Like, what the fuck? This printer's supposed to be for children. This thing is a disaster. Honestly, and okay, right? A failure of a Z-axis causing your print head to slam into your print, causing it to break its heat brake. It's not impossible. I've never really seen it outside of this video. But holy shitballs, this gets bad. Thank God that he was doing this all on Twitch, because someone was able to get in contact with DeWitt over here and get this solved. Good Lord, look at this. I mean, I'm gonna give it credit. It's trying. It's just not doing a great job. At this point, when you've lost your heatsink, your printer should have gone to thermal runaway because it's unable to cool itself. There's no part cooling fan that we can see, although it might share the hot end cooling fan with the part cooling fan, which I hate that method anyways, but we're going to ignore that for now. And it just gets worse. It just gets worse. The whole hot end has basically fallen out. And if you notice, that heater's looking a little loose. Like, this is just bad. There goes the silicone heater sock. There goes the entire heat brake. You might say, Grant, how do you know this thing doesn't have thermal runaway? Do you see the smoke? You see the smoke on the screen? That's how I know the printer doesn't have thermal runaway. Because when a hot end is getting that hot, it's going into thermal runaway. And it should be turning itself off. But this printer's like, we don't fucking care. We're made for kids. Let's burn the house down. The company that made this, I don't even know who it is. And I don't even think it's in the description. And I'm glad it's not, because they shouldn't get any freaking credit for this. So it keeps going about its merry way for a little bit. And then all of a sudden, the heat block comes off. And ladies and gentlemen of the jury, that is a heater. That is a heater that is unregulated and getting so hot, it's turning cherry fucking red. That is well over 600 degrees Celsius, otherwise known as really fucking hot. This is dangerous. This should be illegal. Thermal runaway, you must take it off of a printer. When you put Marlin on a 3D printer, thermal runaway is part of Marlin. You must program it out of Marlin. It comes stock turned on. And if you are a 3D printer manufacturer and you are putting printers out there without thermal runaway, shame on you. You should be sued because you are providing something that you are negligently saying is completely and utterly fine. You are deliberately removing safety measures. So what can be done here? There is no such thing as a 3D printer for kids. They are hot, and if you don't know what you're doing, you can get burned. Imagine if your kid was using this 3D printer when you weren't around. Little Susie's going to the hospital with third-degree burns. Nobody wants that. I'm surprised the heater never actually itself melted. It's white hot. But the thing that gets me about this entire video is actually how DeWitt handles this. Let's see how he handles it. So we can see him coming back here, looking at it, and calmly just turns it off. That's the most disappointed look I've ever seen.
Thanks for the heads up, and it looks like this printer is going to be going to the trash.
What have we learned here? 1, go subscribe to DeWitt 3D Canada. 2, go subscribe to 3D Musketeers. 3, leave a like on both videos because help out the creators you like. But 4, 3D printers meant for children are dangerous. And 5, as reviewers, as content creators, as individuals in this industry, as makers, as whatever the hell you want to call yourself, we need to be doing better about holding companies accountable. The first thing that we do when we get a printer into test is verify that it has thermal runaway. Literally to the point where in the $50 3D printer video that we did, I'll card to it, it was a while back. Boy, have we changed since then. I was waiting for it to not have thermal runaway protection so I could let it light on fire on my bench. I was ready. I had a metal cookie sheet off camera so we could put it on there and let it catch itself on fire. But even the $50 garbage 3D printer from Amazon actually had thermal runaway. It didn't have a screen. It required to basically be ran via a computer. Otherwise, it would only print the first file on the micro SD card. It did not have a standardized extruder. It didn't even use stepper motors for the extruder. It used a standard DC motor. But even that piece of utter crap did better than this. And they didn't call that thing a 3D printer for children. I hate when companies do this. Now, DeWitt, dude, you handled this like a freaking champ. A+ to you. Like, I would have not. This thing, I would have gone and got the band hammer and started beating the hell out of this. I would have probably popped a fire extinguisher just to be safe. We can't let companies get away with this as makers, because every single time a company is allowed to put something like this out there, a grandparent, a parent, a family friend, somebody buys this for a kid. The kid uses it. It either causes damage to the machine, damage to the kid, damage to property, or even further damage to life. And what happens? Our industry is hurt. Our fucking industry is hurt by terrible decisions by companies like this. And I'm fucking tired of it. And if that means that I have to start a company to hold companies like this accountable, I will. And I am working on something like that behind the scenes. So if you want to get involved in something like this to help keep companies from doing dumb shit like this, hit me up, YouTube at 3dmusketeers.com. And if you get a printer that doesn't have thermal runaway, 1, name and shame, because there's no excuse. 2, throw it away. 3, blacklist the company from the industry. Period. And look, honest mistakes can happen. Thermal runaway being deactivated is not an honest mistake. You must deliberately remove thermal runaway protection, or you've built your own printer firmware and you don't know what the hell you're doing. Use Marlin like everybody that doesn't use a Duet or Duet clone. There's a reason why Marlin is so good. There's a reason why well over 70% of the industry uses Marlin. Works. It works well. And it has all the safety measures built right in from the factory. And it's open source. So if you program this stuff out, shame on you. We have to keep companies accountable. If we don't keep companies accountable, they keep getting away with stuff like this. And products like this go out on the market. Now, maybe they got lucky, right? Even a printer without thermal runaway will be able to at least regulate temperature while it can detect the temperature. If the thermistor never reads a higher temperature, let's say it's cut, it's not touching the heater anymore, or it's for some reason been unplugged, the heater will continue to heat until it melts. And we're very lucky here that that didn't happen. Although, not gonna lie, mildly curious to see what would have happened had it did start to melt. And if you want to see that, make sure you get subscribed because that is coming up on the channel. Yeah, I've got a bad printer and we're going to destroy it. DeWitt, if you're watching this, name and shame in the comments, I'll pin it. But I had no desire to even look it up because I don't want to go to the company's website, I don't want to give them another click, and I don't want to put their name in this video. But the name I will put in this video is 3D Musketeers. If you want to help us out, what we do here by making awesome content for you multiple times a week, you can kick a little bit of money to our creator fund over on Patreon, or you can join YouTube channel memberships. All of that will be linked down in the description down below. That's all I have for you guys today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Why does this shit keep happening? And if you notice, ladies and gentlemen, that nozzle is wiggling harder than a wacky wiggling inflatable arm flailing tube man.
This is a real B&H
Motherfucker, there's an ad! Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. If you're looking for something else to watch, check out the rest of the Print Fix Friday series right below me, and right next to me is going to be the entire printer maintenance series. I will see you guys down in those comments where I'm hoping for some spicy meatballs, and in the next one, take care.